Most people believe that lightning rods attract lightning, but actually the contrary is true, and let's see why. So we have this lightning rod mounted on top of this home, and it's connected by this wire to this grounding pin. This pin is hammered down into the earth. And we have this negative cloud that has come over the top of this house and this tree. The earth becomes polarized because soil, believe it or not, is very conductive. The earth is just a very large conductor, and so electrons are pushed away from the surface of the earth, and the top of the earth becomes positively charged. Okay, so also this idea of polarization, that's an idea of polarization, the charge moving away from the surface of the earth. Because this is a conductor, electrons will be pushed out of the conductor down and into the earth by the cloud. Whenever they get to the earth, they're pushed away from this grounding pin like this. Okay? Now, as a result, this rod becomes positively charged. And right here at this tip, there's a high charge density. So, right here, there's a very large electric field. So let's consider an atom in that general region. We'll draw a positive nucleus, and we'll use a planetary model with an electron going in orbit around. So here's the electron. Okay, so because this cloud has come over the top, the electron will be pushed to this side. It will be pushed furthest away from the cloud. The proton will be pulled this way by a force because opposites attract and likes repel. So it repels the electron and attracts the protons. And so this electron will be pushed on this way by this force here. Okay? Now also contributing to that force is this rod, which is positively charged. It's attracting the electrons. And so this atom is torn apart, and the electron jumps onto the rod. Now once it's onto the rod, the cloud pushes it down through the conductor to Earth, and then it goes away from the surface of the Earth. Now this positive ion that's left over, this ion goes up into the cloud. The technical term is that this is a positive streamer. This happens many times per second, and a bunch of ions, positive ions, go up into the cloud. An ion is any atom that has charge. Okay, so this atom lacks electrons. It's not neutral anymore, so it's a positive ion. When these ions get up to the cloud, each ion will neutralize one of these electrons. So these ions will come up to the cloud and they'll capture an electron, and so they're neutralizing this region of the cloud. And the region that they're neutralizing is right above the structure. So lightning rods, not only do they not attract lightning, they prevent lightning from striking structures because of this ionization process that's called coronal discharge. Okay, so this one, I know this is not an easy one to accept, so we're going to do an experiment to verify it. We've got this Van de Graaff generator here. And how this Van de Graaff generator works is this large bolt, this globe here, it's a metal globe, and there's a belt in this column here. This belt takes electrons off this globe, moves them up this wire, down into this box that's out of the view, through the box, and up this wire to this smaller ball. This is called the grounding rod. So this globe becomes positively charged, and this ball here becomes negatively charged. So this is like the Earth, and this is like the cloud. Okay, so we're going to turn this on, and I'm going to change some settings. Turn this on now. I'm going to change some settings on the camera to make it easier for you to see. I'm going to zoom in here. Okay, we're back. I adjusted some settings on the camera and also lowered the lighting in the room. This is the top of the globe that we were looking at earlier. And here's a paper clip. This is a paper clip that I've taken and I've chopped it up with some pliers. And we're going to tape this paper clip to the top of the globe so as to create a lightning rod. So I'm going to use some Scotch tape here, and I'm just going to tape it right onto the top here like so. Okay? So according to our model, the globe will be positively charged and the paperclip will also be positively charged. And so there should not be lightning striking here in this region here. There should not be sparking in that region. Let's see what happens. Okay, so the Van de Graaff is now, the rubber belt is sucking electrons off of the globe and moving them into this smaller sphere here, the smaller sphere that I'm holding in my hand here, which I'll bring into view in just a moment. Let's see if I can move the Van de Graaff into the center there. There we go. Okay, here we go. Here we go. Bringing the globe in. So we see the striking all around. I'm moving it back and forward. But whenever I move towards the lightning rod, there shouldn't be any sparking. And sure enough, there's no sparking. Move away. Notice, see that? Okay, so the lightning rod, there's coronal discharge going on the top of it. And so those positive ions, whenever we get close to it, those positive ions are neutralizing the ball.